today I will show you some features that currently are available in MDTools 780 version, and they will then be also added to MDTools 900 for SolidWorks. So some commands will be specific to MDTools for Inventor for the moment. The first webinar we had last month, I designed something similar to what you see here. So I already have this assembly, but today my task is showing you how to design mating manifolds. So I will start from the old design, where I had two NG16 and one NG6 valve. And I will design this manifold that is in between here. And I will make a full assembly of the two manifolds. And my initial manifold is this one, and I have my block that I will open, and that's my starting subplate. This one will change to have the top manifold that I will be designing today. To save some time, I will design starting from a HydroCAD diagram. So I will just run the export to MDTools only for the top manifold. And this will be my interface. And as you can see, we have nets in our diagram. And I can export this file and save into my design folder, which is my mating manifolds. That's the mating circuit. I go back to Inventor, and as you see, this is my subplate. On top, I will need to have my additional block. Let me prepare the subplate. So I just remove the first NG16 valve, and I will add some material to my block. Maybe on the length, I will add, let's say, 100 millimeter. But later I will assemble on top of it the manifold. So now I'll stop here for the subplate. This is where my manifold will be positioned. But let's start for the top manifold. As I'm starting with HydroCAD, I will load my HydroCAD diagram, which is in the mating manifold folder, and is the mating circuit. It's not a very complicated diagram, so we will do relatively fast for the design. I will start for a manifold. Since we have an NG16 with a relatively large valve and an NG10, in this case, I will start maybe with a 200 millimeter block, 160 by width, and 80 millimeters should be enough for the size. And let me start placing the component. Double click, and we place on the top face. We can rotate the valve, and let me position this valve here. And I do the same for the second one. Insert, position, rotate, and let me place it randomly here. Let me just move the engravings. Or later we can also remove the engraving. That's not important. And nets, we can find all the other components. So A port, let's say that we will put the A port just in the center with the same NG16 port at 0, 0. I also take the B port, place here, position with reference to the other cavity. And let me just stretch this rail. And also this one. Let us place the P port. Maybe we put the P port somewhere here. A reference to this cavity at 0.45. As a strategy, I will try to connect the yellow and orange in the center in order to save space and reduce the number of plugs. I will, let me check which settings I have for the construction plug settings. Construction plug from last manifold I made, I had expander. So let me load the BSP plugs and apply. So now I'll do an export construction port to connect the P line. 1 by 2 is enough, and I will position on this place. I want to connect the pressure here and align with this cavity 0. And also I copy the same plug, position here, and connect here and here. And maybe we position. Let's use the bottom drill and position aligned in the center. We connect the yellow lines, continue on this face. And as we have a red drill passing through, we want to keep at least 5 millimeters below this drill. And let's make an additional 1, 2, 3 millimeters. We do the same for the other drill. Position here, and we move it here. Let's take the tank line, and we position it here in the center. Sorry, in the center. And we can stretch our drill on top. Let's connect the tank lines, construction plug, tangent, and let's copy to make another connection. Connecting here and connecting here. We miss the drain line, and I want to bring the drain on the opposite side. So let me place the drain port somewhere here. I will make a construction port on the drain and position it on this face. Let's move it slightly on the X direction. And let's make an inclined connection here, stretch with inclination going here. Slightly less, 22 degrees. MDTools is warning because now the shape for the inclined drill will exceed the maximum shape allowed by the drill. The maximum value I can make is 6.49, so I will make it 6 millimeter. That's enough for the drain. Let me save my block. Let's save, and that's my top block. Top block. I don't need the X and leakage port on this footprint. Of course, I will need to mount my manifold, so I will need at least 4 mounting holes. So let me add 4 mounting holes on the bottom face. I will need some pass-through M10, 4 bolt holes on the bottom face. That's good. I will need some extra space. So let me add some more material on the right of the manifold. Let's say I add 10 millimeters on this direction. And I also want some more material on the left. So you drag the plane, and let's say 5 millimeters should be enough. My block is can be reduced in width. So in width, we can drag the cursor and remove maybe 15 millimeters here. Now this manifold will be assembled directly on top of the subplate and I need some O-ring grooves. I don't need engravings on the bottom face, so I go to Manage and remove my engravings for A, B, P, D, and Y, and also 9. That's not needed. I delete all the engravings. And now I want to add some O-ring grooves. There is a command to add O-ring grooves. O-ring groove, I want to add on the tank line. I will add maybe a O-ring 120 size. Okay. I do the same O-ring for this. Same 120 size. O-ring 120. O-ring 120. And we add an O-ring also here. And let's stay with well, no, let me take a 262 of let's take the 112. That's good. Let us verify quickly the block, although we will have a specific webinar. Next one will be describing all the checking we can do on the manifold. With a connection check, we can verify if we made all the connection properly. I will not fix anything. I will just say that's okay. And also for the wall thickness, you can check the block, let's say 4 millimeters, and we do a check, and that's okay. Our block looks good. Now let me save my block. I want to make an assembly to verify if my block is okay with the vase that will go on top of it. So I will make an automatic assembly of my block, which is my top block. And now MDTools will place all the components. Since I started from Hydro, I have linked all the 3D models in HydroCAD, so the assembly is very, very easy, and it is done. And I can see the assembly is good. I can save some room, actually looking at this. I can remove some material in between and also on the side of the NG16. So let me try to see if I can remove, let's see, 5 millimeters on the right. Here, remove 5 millimeters. And also in between, maybe we remove some extra millimeters. That's okay. Let's remove 5 millimeters. We go back to the assembly, we update, and that's fine. Okay, now I think I added material instead of removing. Let me do again, removing. Remove 10 millimeters. Let's check. Looks good. And later we can have a counterbore on top of this drill, but let's not do now. I go back to my top block, and now I use 2 commands. The first one is called make footprint. This is new in MDTools 700. It will be available in 900 series as well. This command is able to create a footprint on the fly on a manifold. My footprint is made by all my bolt holes and then all my drills. We can give a port name, because as you are aware, each footprint will be made of drill holes with a name. In this case, the name of the port is identical to the port name, but it could be different. We can specify the dimension from. This is a setting that will have impact in the machining drawing of the block. We can specify a component ID. Let's say that the name is mating face. And we can, if we want, we can change the footprint outline. This is okay, but we can specify a different shape of the outline if it is needed. It can be a rectangle or a circle. When we click OK, MDTools will create a footprint on the fly made of all these drills. And if we go on the model, now we see that our block is made of 3 footprints. One is the NG16, NG10, and also the bottom face. The second special command we use today is the mirror footprint. So this command can mirror the footprint of one block, and it will ask to select which type of drills. So in this case, the source block has pass-through bolt holes. So MDTools is suggesting me M10 size. And on the opposite, if your source block has maybe M10, MDTools will suggest you pass-through bolt hole on the mating manifold. In this case, this is okay. I need the threaded hole on the subplate. M10 is good. We click OK, and now MDTools is asking the destination block, which was my starting block. I go on the starting block and touch the face of the block, and I can position in my destination block. And let me put it here. And that's my top block. We need to specify a name of the footprint in the new destination block. I had specified the same net name, so I don't have any issue with colors. The net information is the same. And now I just need to finish my block here. I can delete a plug. And I can just connect straight with the pressure. I can use the align multiple cavities to align these 2 cavities with the new position for A and B port. I can match properties from this drill to the other and copy all the geometry, alpha, beta, and so on to make the same connection. I can connect my tank line. As you can see, I have the drain line here. If you remember the diagram, in the diagram, the drain is ending in the tank line. So they have no separate net in the subplate. So I will just go into my manifold and do edit for this net and say, this net is not different, it's just the tank net. So it will become blue. And I will be able to stretch this drill and make the connection. Now that I have this drill, maybe the connection from the test point will be a bit tricky. So let me change the strategy here. I delete the inclined hole. I move my pressure gauge port where I have a lot of space. And also I can move my MA1 and maybe position it somewhere here. I can align both cavities. Align 1 and 2. And I can make a construction port between this and the yellow connection, 1/8 BSP, and I can position on the left face. I don't need such a huge drill, so let me just make it 6 millimeters. Let me recolor the block. And let us verify the connections in the destination block. There is a bad connection. Yes, this was also in the source block. So let's make a better connection for the tank line. Let's make it slightly longer. And the rest is fine. We can verify the wall thickness on our destination block. Let's say 5 millimeters. And here we can go through, maybe here we see that we have not enough space between the bolt holes, but that should not be a big deal on the block. I don't fear anything here. And the same here, we have not a lot of distance between the bolt holes. And here we have just 4.4 millimeters between the blue and the pink drills, but that's okay. So we can go through each issues and fix if needed. But the block to me looks good, so let me save it. And I go to my manifold assembly. So let's go to the top assembly and save it. Save as top assembly. And now we go back to the manifold assembly. So the manifold assembly requires update, and we can update with all the commands. And we can remove this solenoid valve is not needed anymore. It has been replaced by our manifold, but still there is an update pending. If you remember, we have removed a plug from the original subplate. So by clicking update, the plug will be removed from the, and as you see here, there was a shape that disappeared. We have a new plug, so to make sure that we don't forget any construction plug, we just click again plug command, and now the new construction plug is added to my block. All the constraints are added, and now let me add let me save my assembly, and I want to add the top manifold on top here. And let me constrain it. So here I'm using the inventor constraints and concentric. And of course, I will make this concentric, this one with this one. My manifold assembly is complete. Let's check all the connections. So I go to my top block and do a tricky command that is remove face. I go also on the starting block and remove the face. And let's go back to the top assembly and to the manifold assembly. So here we can see that all the connections have been made properly in the same position. We can verify O-rings, all the connection, or directly in the 3D model. Just highlight what is missing in MDTools 900 for SolidWorks. Basically, there you will not find these two commands, the mirror footprint and the make footprint. To create the mating manifolds in SolidWorks, in those cases, either you create the footprint in the library, which is one option, or you can use other techniques, which will be not, I don't have enough time to show, but I will be happy to explain it to users for SolidWorks if they have any specific need. So basically, we can project the drills from one block to another directly in the assembly space. There is another interesting command that can be used in case of this is frequently added when you need to make a manifold that is assembled on a cylinder, where normally the pattern of the bolt holes is not a rectangle, but it's maybe circular pattern. This is also another slightly hidden command, so let me show how it works. And maybe we have a drill 20 millimeters on a face. and we have a bolt hole, let's say M10, and that's bolt hole 1, and maybe this bolt hole is position at a reference 0, 30. We have a command called copy circular. We can select the bolt hole, select the destination drill, and maybe make 5 drills circular pattern. And in this way, we can make a custom pattern of circular drills around a cavity. Interestingly, we can then make the footprint on the fly. And now the shape will be a circular shape, but you can change and make it rectangular, and that's maybe the P port of the footprint. That's a special flange. Let me show you what happens if we want to mirror this. So in the first exercise, we were starting from pass-through bolt holes. Now we start from skew bolt holes, so from threads. And let me make a new block as a destination. 200 by 200 by 200. And now I want to mirror this footprint. Now that the dialog is slightly different, by default, since we are starting from a thread, MDTools is asking if we want to pass through, and I want also a spot face on the opposite. And I will select the library, which is my pass bolt holes, and the cavity is the TCEI M10. And I also can select an O-ring, which now in this case is not adding, no problem. I will add later the O-ring. And I click OK. And I go to the destination block and place it here. That's my new footprint. And in this case, the footprint is made with pass-through bolt holes on the opposite side. And here we can add the O-ring on this.